Hello and welcome. My name is Vik Bhatia, and in this video series, we're going to walk through the installation and configuration of Information Server 11502 on a Linux platform using Oracle RDBMS for the metadata repository. My goal is to show you the installation process in great detail. The focus of this video is going to, therefore, be on that specific aspect. Issues or details or considerations for capacity planning, for scalability, for parallel processing, etc., are not part of this demonstration, and that's pretty much because those aspects are, although valuable, but they vary greatly from one organization to another. But the actual process of installation and configuration remains largely the same. So the goal is to focus on that in this video series. So let's get started. So here's what our technology stack will look like. We're going to use Red Hat Linux 7 64-bit, Oracle RDBMS 12c Release 1, and this is version 12.1.0.2. Please note, Oracle Release 2 for 12c has also been released and available for download. IBM has not yet supported this particular version for Information Server Repository. So if you were to use it, the installation process itself is going to fail with a certain error. So we're going to stay with 12c Release 1. We can also use 11G. So anything 12c Release 1 or lower would work. Information Server 11502 is the software we're going to use, and we're putting this on a laptop computer in my case. You can use a laptop or desktop or any other server, but you must have, or at least I recommend that you have at least 16 gigabytes of RAM and 2 CPU cores dedicated to this task. So our first step is to get Linux and Oracle RDBMS on our laptop computer. Now, for this purpose, I'm going to use a pre-built appliance from Oracle. It's called VirtualBox, and it's a virtualization solution. It comes with Oracle pre-installed on Linux 7. And so what we're going to do is go to Oracle Technology Network, download VirtualBox software, and then download the VirtualBox, a pre-built appliance that contains Linux and Oracle RDBMS. So let's do that. So in your browser, go to Oracle Technology Network. That's http://otn.oracle.com. And here we're going to go to this little waffle menu. But first, you got to log in. So if you haven't logged in, or if you don't have an account, do create yourself a free account and then log in. And once you're logged in, you'll see that you're in here with an active session. So now we'll go to this waffle menu, click on OTN, choose Pre-Built Developer VMs, and over here you'll download two things. One, Oracle VirtualBox, which is the actual virtualization software. So you need to install this on your computer. So if you're on a Windows, you'll download the Windows version. If you're on a Mac or a Linux, you get the appropriate version for your platform. And then you're going to get a pre-built appliance that will run on top of that software. And in our case, we'll get Database App Development VM. So if you click on that, it's available right here. It contains Oracle Linux 7, Oracle Database 12c Release 2 Enterprise Edition. Again, I said earlier that Release 2 is not supported for metadata repository. I do have a Release 1 on my computer, and that's what I'm going to use, but I'm just basically showing you where to get the actual developer VM with the appropriate technology stack for doing this installation. So I'm hoping that in the near future, Release 2 will also be supported for IBM Information Server Repository. So at that point, you'll be able to use this. But till then, you might want to look at this list over here and find one that has Release 1 and use that one. But this is what I'm using, but a one release older copy. You click on this link and you download it, and basically that's it. And once you have it on your computer, you set it up, and then you simply import the appliance into your software, and I'll show you how to do that next. So here I have my VirtualBox application open, and this is the Oracle VM VirtualBox Manager, and this has two virtual machines available in it. The one is powered off, the other one says saved. So once you've downloaded the Oracle virtual machine appliance, you can import it here using the import utility that this provides. And this is how you do it. You simply go to File and then say Import Appliance. And it brings up a little import window. And it's looking for appliance in the OVA format. That stands for Open Virtual Appliance. And so you can click on this little folder icon to browse to the location where you downloaded the OVA file, or if you know the location, you can simply put it here. And so this is the OVA file I'm going to import, and then just simply click on the import button. And you agree to the terms and conditions, and it will at this point start importing the appliance into your VirtualBox application. So this will take probably a couple of minutes, and once it's done, you can simply click on the start button to launch it. So as you can see, the import is almost complete here, and once it's done, we'll see a third entry here, and this is the one we just imported. And we can just click on this and click on the start button, and it will start this appliance for us. Now before we do that, we need to do a couple of things. Basically, those will involve giving the virtual machine a little more resources than the default that it comes with. So one of the things you'll notice is that under System, you've got base memory of 2 gigs. You want to change this to a much larger, maybe 4 or 6 if you can do that. So you click on System, you go to the memory. I'm going to change it to 6 gigs, which would be 6144 MB. And then you go to the processor tab, and over here it's got 1 CPU core. I'm going to make this 2. So you make these 2 changes and save it, and now you can start this virtual machine by simply clicking the start button. And let's go ahead and do that. And this takes about a couple minutes to come up, but when it's ready to go, you basically have a complete Linux and Oracle environment that is ready for use. So here our machine is up, and we can basically make the window a little bit larger so it's easier to read. So we're next going to quickly explore Oracle, see everything is up and running, and then start doing the basic configuration work necessary to install Information Server. So we're back inside our virtual machine, and I'm going to go ahead and start up a terminal session so we can go take a look at Oracle and other services that are running here. So right click on your virtual machine window desktop and say open in terminal or open a terminal. So this is the terminal window that comes up. A couple of things to note here. Under database information, you can see the Oracle SID is CDB1. And then there's also a pluggable database instance called ORCL. Okay, and if you're unfamiliar with Oracle, the Oracle SID refers to a container database, and the pluggable database is actually another database instance inside of that container database. So this is a 12c feature where a database can contain multiple pluggable databases. All the passwords for all the accounts on this virtual machine are Oracle. So we'll probably stick with that convention. So as we add new accounts for purposes of our install, we will keep the passwords as Oracle, so it's consistent and you don't have to worry about it. Obviously in production, this is not something we would do. So whenever you start this virtual machine, the Oracle server processes will start up automatically. And to get a list of those processes, you can simply run a ps command and look for process names starting with ORA underscore. And there's a whole bunch of them here. And I believe there's maybe close to 70 of them. So if I just pipe this to a word count, you'll see there's 66 processes that are running. So the next thing we're going to do is connect to Oracle and take a look inside the database. But before we do that, let's actually take a look at the environment that is available to us at our terminal session level. So there are 3 environment variables that are of interest here. We're going to look at those. But one thing I want to point out is that because we started the terminal session from the desktop by right-clicking on the desktop and choosing Open in Terminal, it does not source the Oracle environment into your terminal window. However, if you go up to your Applications menu and then click on under Favorites, go to Terminal, it does pick up the Oracle environment correctly in the terminal session that comes up. So here's what I mean. If I go ahead and in the first terminal window type env and then basically just grep for Oracle, I get nothing. Over here, I do the same thing. You can see that there's a couple of Oracle environment variables that popped up. So I wanted to make sure you to point this difference out to you in case you're left wondering why certain things aren't working when you start a terminal session from your desktop directly. So here we see two different environment variables starting with Oracle, the Oracle SID that points to CDB1 and Oracle underscore home, which is the location where all of the Oracle software is installed, is in this particular location. And the reason this is important is that there is a bin directory under this location, and you want to include that in your path. And if it's not in your path, you're not going to be able to run some of the Oracle client tools from your terminal. So if I say echo $path, you'll see that Oracle Home bin, which is this particular location, is in your path variable, and that allows you to invoke tools like SQL Plus, etc. from your terminal command line. The other variable that I wanted to point out is called toTask. And the toTask is an interesting variable. It basically defines when you're making a TNS or SQLnet connection, it defines the default database instance that your connection will go to. So in this case, it's ORCL. And recall that the ORCL is the pluggable database inside of the container database CDB1. So when you're making a connection and you say something like SQL Plus username / password and you hit enter, it's going to go to ORCL. It's not going to go to CDB1. So that's what toTask does. Now let's go ahead and connect our Oracle instance and take a look around. So we're going to use SQL Plus as the command line tool to connect to Oracle, and we are going to connect a system. Hit enter. The password is Oracle. So we pass in our password and this confirms that we're connected. So because toTask was an action, the database instance it connected or passed a connection to is ORCL, and we are connected as system. So let's quickly confirm that. When I type show user, it tells me I am system. And if I say show container underscore name, now the container I'm connected to is ORCL. So recall there are two containers here, the CDB1, and inside CDB1 we have the ORCL instance. So that's the one we're connected to. So this looks really good. Our database is up, we're successfully connected, and we can now move on to the next step. Okay, so before we get into the details of product installation, let me take a few minutes to familiarize you with the installation documentation. So I have the documentation up on your screen here, and I'm going to go ahead and open up the table of contents. We're going to first start by looking at the server topologies, and that would be under installing, and then installing software, planning for installation, and then understanding installation options, choosing a topology, it's a lot of clicks, and then designing an installation topology. So within here we have the basic topologies, and this is basically how you're going to segregate the various components of your technology stack to support the information server itself. So here we have, for example, the single computer topology, and what this is basically you have one computer. it's going to contain your client tier, engine tier, services, metadata repository, and everything's on the same box. So it would be typically like a Windows computer where you have your data stage designer, director, and other client tools on it. And then you also install your engine and services tier as well as the metadata repository on the same Windows computer. That's not what we're doing here, although it may kind of seem that way. What we're doing actually is a client-server topology. And what this is that you have a client tier that's separate from the actual server tier where all of your remaining components, mainly your engine tier, your services tier, and the metadata repository are available. So in our case, the virtual machine is computer B, and the computer that the virtual machine itself is running on, which could be a Windows computer, is the computer A, where all the client tools are going to be installed. So we're going to use the virtual network on the computer to connect to the virtual machine where all the server components are running. So this is what we're going to be using in this particular demo. So the other topologies here include a dedicated engine tier topology, where the engine itself is separate from the services and metadata repository. We also have a dedicated computer for each tier of the topology, and so you've got 4 different tiers: client, services, metadata, and engine. So you basically have 4 computers and so on. And so if you're interested in looking at these in more detail, feel free to go to the documentation and check it out. Now let's take a look at the server configuration that we're going to work with in order to get the installation underway. So we're going to create and mount a file system for our install, and that's going to be a dedicated disk. I'm going to show you how to do that with VirtualBox. Then we're going to create an engine account on the operating system, and the account is DSADM, and the purpose of this account is to basically run the data stage engine. And last but not least, we're also going to set some kernel parameters for purposes of the installation and information server requirement. So these are, again, quickly, let's go to that in the documentation here. We will go to installing or maybe setting up the tier computers and then modifying kernel parameters and user limits. So this is what we're going to do. Just quickly here, the minimum kernel parameter values for IBM DB2 databases. So we're not doing that. We are using Oracle, so we can skip right over this. And then we have the minimum Linux kernel parameters that we are going to use for information server. So they're basically 3 different classes of parameters. There's the MSG, the SEM, and the SHM, so shared memory, semaphores, and then of course we have the number of user processes and the number of open files that you can have. So these are the parameters we're going to look at real quick, set them up for the right levels as indicated in the documentation, and then we can just have the installation started. Okay, so here I have our documentation and a terminal window side by side, so we can inspect the values of these various parameters through our terminal window and make any adjustments as necessary. So first things first, change your connection to root. So sudo -s will do that for us. And so now we're in as root. We're simply going to look at the kernel parameters that are stored in the sysctl.conf file. Easy way to look at that would be simply say sysctl -a and then grep for MSG. So let's do that instead. So here are the various MSG specific parameters. The ones we're interested in: MSG max. MSG max is set to 8192, so we're okay there, nothing to change. MSG MNB is set to 16384. Again, that meets the requirement, so nothing to change there. MSG MNI is not a requirement for this installation. It's set to a certain value. We'll leave it alone. So everything's good there. Let's go to the next one. Let's look at SEM. Actually, I'm going to look at SHM first, and then we'll do SEM last. So in SHM series of parameters, our SHM all is set to 205058, and this one is looking for um, a different value, a much larger value, but it also says that use the smaller value of this if the following conditions apply. The computer has only the minimum memory. It says 4 GB, we have 8, so we can either go with a higher one or probably go with this one still. The computer does not have a metadata repository with DB2, so we don't have that, so we meet that requirement. The page size is 4096. So we can take a look at the page size and confirm that it is 4096. Right here, we'll just type in getconf and then page size. And that should tell us our page size is 4096. So that actually meets the requirement. But the SHM all is what we need to adjust. And SHM max in our terminal window is set to a larger value than what the documentation calls for, so we can just leave it alone. So let's go ahead and change SHM max. Using the sysctl command, we can change the kernel parameter, and this is what we did. We just typed this in, and it changes it to the value that we desire. Now the same thing, if we want to go ahead and make other changes, we'll continue to do sysctl -w. However, to make our changes permanent so that they survive system reboot, we need to write this out to the sysctl.conf file. So to write it out to sysctl.conf file, we basically append this particular line to the etc sysctl.conf file. So there we go. So we need to do that step to make sure that our changes survive reboot. So that takes care of SHM all. We already determined SHM max and SHM MNI are appropriately set. Now let us look at the SEM series of parameters. So it's SEM MNI, SEM MNS, and SEM MSL. And of course another one, SEM OPM. So if we simply do a sysctl command again, sysctl -a, and we're going to grep for SEM. Now this gives us one line, and it gives us all 4 parameters in one single line. So our SEM MSL is 250, SEM MNS is 32,000, SEM OPM is 100, and then SEM MNI is 128. So now to change this, we are going to do it again in just one line change instead of changing 4 separate values. And the sysctlw command would do that for us. So we're setting it to 250, 128,000, 32, and 1024, which are the recommended values per the documentation. And so that takes care of that. And then of course we need to write this out to our sysctl.conf file to make the changes permanent. So this is the part we're going to write out. So I'm going to highlight this here, copy it, and then just say echo, and paste that, and we're going to send this to /etc/sysctl.conf, and that will take care of that. So all the kernel parameters are set. There are 2 things left to verify, the nproc and the number of open files. So both of these parameters are set as limits in the etc securities limits.conf file. So let's look at that one. So let's go ahead and take a look at that file, vi/etc security limits.conf. And we go to the very bottom of the file. I've already made my changes. I just want to point these out, what those changes are. Basically 3 things over here. Hard limit for the number of processes set to 16384. This is 1000 or unlimited per the documentation, so we're simply going to keep the 16384. The soft limit for number of open files is 10240, and that's what the documentation calls for. The hard limit is a little bit larger than that, so this is what what it was set to when I edited the file, so I just left it alone. Now, the asterisk in the first column simply indicate that these limits apply to all users of this operating system. So that's what we want. This looks good. I'm going to go ahead and quit out of this. And before we run the installer, one of the things we have to do is make sure that the terminal window from where we're going to run the installer will have the correct limits for the number of open files and the number of processes. Now this is because the changes we just made went into the limits.conf file, which is going to be read the next time we reboot the computer. So at this point, if you want to check what the limit is set to, you simply use the ulimit command, capital S for soft and for number of open files, and that's set to 1024. So obviously that needs to change, and that's very simple to do so. You simply type ulimit minus SN followed by the number, so 10240. And now go back to that command and it tells you it's set correctly. And the same thing for the hard limit. You would say ulimit minus HN, and let's see what that's set to. That's set to a number higher than 10240, so we're just going to leave that alone. So we're done with this. There's one more step that's not in the documentation that we should do, at least for our virtual machine, which is to make sure you have the package libxp installed. So yum install, do this as root, lib capital XP. So in my case, libxp is already installed, so there's really nothing to do here, but it does not come installed by default, so this is a step you'll have to do if you're performing this install on the Oracle VM. Okay, so time to take a quick progress checkpoint. So we have so far downloaded the Linux virtual machine and the VirtualBox software. We set it up, configured it, imported the virtual machine appliance, and took a look around, looked at the Oracle setup, the container database, and the pluggable database in there. And then we went on to look at some documentation for information server installation, reviewed some topologies, looked at the kernel parameter settings per the documentation, and adjusted the ones that needed adjustment. So we're ready to move on to the next step. And the next step is going to be to create a user account at the Linux level, and that's the DSADM account, which will run our information server data stage engine. We're also going to add a brand new disk and file system and create a file system on that disk, and that's where the information server software is going to be installed. So let's get on with it. So back in the terminal window, let's take a look at all the operating system accounts we have currently set up, or that came set up on this virtual machine. So if we cat the etc password file, that's a quick way to look at them all on your screen. And we don't have an account here for DSADM. Now there's a couple of things we can do. There is an application that comes with your Linux environment, and it's called under System Tools. You go into Settings, and then there's a familiar looking interface. You can click on Users and add new users here. What I'm going to do is simply run the user add command. User add minus D tells you all the defaults that are set up when you create a user. So it's going to be basically we're going to create a home directory for this user in /home. It's going to have bin bash as the shell, and so on. So simply saying user add DSADM should create the DSADM account for us. Okay, you can ignore this mailbox message. It just means that I used to have a DSADM account on this virtual machine. You probably will not see it. But now if I run etc password, you should see a DSADM account at the very bottom. We don't really care about the group membership of this particular account for this install, but when you do a real install on a server, you probably will have a separate group for DSADM, so you can manage your security policies at the group level and at the account level. But we don't worry about that over here. But what we do want to do is set up a password for DSADM. So since we're in as root, we can just say password DSADM, and keeping in the spirit of this virtual machine, again, passwords are going to be Oracle. So here's the password. It tells us that it's not a very nice password, but we'll nevertheless keep it. Now, of course, standard disclaimer applies here for real installs, production installs, or even if you're doing any kind of server install, you should use strong passwords. So this is done. We've got the account. It's set up with a password Oracle, and we can move on to now the next step here.
So our next step is to create a new disk and attach it to this virtual machine. And to do that, we're going to first shut down this virtual machine, go into our virtual box manager, and create a new disk there and attach it to this virtual machine at the hardware level. So our hardware is virtual, so it's basically attaching it to the virtual hardware. Then we start this virtual machine back up, and then the disk will be available or visible to this virtual machine. It won't be configured, and it won't have a file system yet. So that's what we're going to do to the virtual to this virtual disk. Once it's visible to the virtual machine, we'll create a new file system. We'll mount this disk to a specific mount point on our root partition, which is /u02. And then the purpose of this disk is to have or to install the information server software. So all of that information server software is going to be on this new disk. Okay, so let's get that started. So here we are. We're going to go ahead and click on the username Oracle at the top right hand corner of your window, and then choose the power off option, and then click the power off button, and this will shut off your virtual machine. Okay, so the virtual machine is turned off, so it says powered off, and we're in the VirtualBox Manager. And to add a new disk, we go into the storage. So make sure the virtual machine is selected, the correct virtual machine is selected. Go to storage, and there's a SATA controller. Click on that. And then right now my virtual machine has 3 disks attached to it. Okay, yours may have 2 if it's a brand new virtual machine out of the box, but we can add more disks to it. So I'm going to click on this little plus icon next to on the controller line, and that would add a hard disk. So we're going to create a new disk, and it's going to be a virtual machine disk, so VMDK. Click continue. We will make this dynamically allocated. So my thinking is we'll keep the disk at about 30 gigs, but it's going to start off much less, and then it's going to expand as the needs grow to a maximum size of 30 gigabytes. So click continue. We're going to call this, let's call this IBM underscore information server disk. Okay, and we'll make this 30 gigabytes and say create. So now we have this new disk that's been created, and it's available, and it's attached to this virtual machine. So since we're doing everything in context of this virtual machine, so it's already attached to it, we'll click OK, and now we can go ahead and start this virtual machine back up. So let's do that. Okay, so we're back in our virtual machine. Everything came up. Let's go ahead and start a terminal session. And we opened a new terminal. We're going to go in as root. So sudo -s will get us in as root. And typically you can do an fdisk command over here to look at all the disks that are available on this virtual machine. There's also a really nice and handy disk utility. Let's fire that up. We're going to click on applications and then go to utilities. And then there's one called disks. So click on that. You can see now all the hard disks that are available to us on this virtual machine. And the one we just added is probably the one towards the bottom. and it says 32 gigabytes, and the file system is unknown. Now compare that to this one, which is also 32 gigabytes. Its file system is XFS. So we're basically going to create a file system on this new disk. Click on this little gear here, the More Actions button, and we'll say Format. And the type of file system we want, let's go ahead with a custom file system. We'll create XFS. So erase the BTRFS and replace it with XFS. And go ahead and say Format. And it wants a password. So the password is Oracle. Click Authenticate. And so now this is formatted to be XFS. Now this file system is not mounted anywhere, so it says not mounted. So we want to mount this. So let's create a mount point. So back in the terminal window, we're going to create a directory /u02, and that directory is created, so that's where this new file system is going to be mounted. So back into our disk utility, we're going to click on the More Actions button one more time. We'll edit the mount options, and the automatic mount options will turn that off. And for the mount options that are stored in the etcfs tab file, I'm just going to keep, instead of giving these specific options, I'm just going to say defaults. The mount point, we just created one /u02, so that's what we're going to say here. And file system type is XFS. Okay, so say OK to that. Password one more time. And so now this is set up to be mounted. It's still not mounted. The name of the device is dev SDD, and we'll see why this is relevant later on. And we'll just click on this little button over here to mount the file system. One more time, we enter our password, and now it says it's mounted at /u02. Back in the terminal window, if you run df-h, you'll see all the mounted file systems, with this one /dev/std being the latest one we just mounted, right? So now we have a brand new disk attached to this virtual machine with a file system created on it, and it's mounted at /u02. It's that easy.
Okay, so our next step is going to be to install the metadata repository within the Oracle database. So I have the documentation open here. In the documentation table of contents, go to Installing, and under Installing information server software, planning for installs, setting up tier computers, and then pre-installing databases. So that's what we're doing here. We're going to pre-install the metadata repository database. So let's go ahead and open pre-installing metadata repository database. We're not doing DB2, we're doing Oracle database on AIX/Linux. So that's the one we're going to choose. And here we have to do a couple of things. There are scripts that are provided to us, and we need to just run those scripts, and it will create the schema and user accounts and the necessary objects for the metadata repository. So here it's asking you to check a couple of things. The NLS character set should be AL32UTF-8, and then NLS nchar character set should be AL16UTF-16. So let's confirm that. Okay, so let's first connect to our database instance. We will use SQL Plus, connect as system, and the password is Oracle. And we're going to check for the NLS character set and NLS nchar character set. So the table to query for these values is NLS database parameters. Then we're going to run our select statement, select parameter, comma, value from NLS underscore database. This is not case sensitive, by the way. And then we can see that the database NLS nchar character set is set to AL16 UTF-16, which is what the documentation calls for. And then NLS character set is set to AL32 UTF-8, which is also consistent with with what the documentation requires. So we've met those requirements. We can go ahead and run the scripts to create the metadata repository at this point. So let's take a look at what that requires us to do. Basically, um, you need to run the script called create xmetadb.sh and provide the following arguments, and that will create the actual schema and the objects in the database. So let's go ahead and do that. Now to run the script, we're going to go to the folder where we have downloaded and unzipped all of the installation files. So in my case, that is sw/downloads and then is-suite. So in this folder, all the installation files are present. We're going to go into database support and then go to Unix and then Oracle, oh no, I'm sorry, metadata repository, Oracle 12c. And then in here, you'll see there's this file called create xmetadb.sh. So we're going to run that. And the first argument is sys. The password is Oracle. Database name is ORCL. Xmeta is our user. And then Oracle is the password. Xmeta underscore DAT will be our tablespace name. And then I have the location where all the data files will reside in my clipboard. So this is the location. So just go ahead and hit enter at this point. It's going to want you to confirm all the parameters. And then it looks fine to us. We'll just go ahead and click enter. And it tells you that the tablespace was created successfully. And then the metadata repository user was also created successfully. So this step is complete. Let's scroll down here and we're going to do this one more time, and this time for the staging repository user. So exactly the same command, just a different username and a different tablespace. So let's go ahead and repeat this command, and I'm just going to make a couple of changes. One, we don't need a trailing slash here, so I'll take that out. So the user is xmeta sr. So I'm just going to put xmeta sr underscore dat for the tablespace name and xmeta sr for the username. Password remains the same. Everything else remains the same. So just go ahead and hit enter here. Confirm that this looks correct, and it sure does. So we'll go ahead and hit enter, and it should create another tablespace for us and another user for us. So that one's done as well. The last thing we need to do here is to create the information analyzer repository. So this is the metadata repository. Let's collapse that. And here is the information analyzer database. So again, we choose Oracle, not Windows, Oracle Linux, and it's going to have the same basic requirements, just a different script to run. It's called create ia underscore db.sh. So let's go ahead and run that. We are in this particular location. We're going to go back 2 directory levels and then go into, instead of metadata repository, we'll go into information analyzer. So go back 2 levels and we'll go to information analyzer, Oracle, and you'll see the script to run create ia db.sh. So let's run that. So create iadb.sh. Now notice this one doesn't run as sys, it runs as system. So we'll put in the system user, password is Oracle, the account to create, or the DB name is ORCL, IA user is the account, and then Oracle is the password, IA user underscore DAT is the table space, and then of course the data file will go in this location. Okay, so hit enter, confirm that these look correct, and they look fine to me. So we'll just hit enter again, and it should create our information analyzer user, a repository user, and the table space. So we're done with creating the repository at this point. So now that we're done with setting up the metadata repository, we are now ready to move on to installing the information server software. So you do this as root. So I have a window here open as root, and my software is downloaded and unzipped in the SW downloads folder. And when you unzip the information server zip file, you will get a folder is-suite. So this is the folder that's created. So I'm going to go in there, and then I will run the setup program. So you can just do a quick ls to show you what's in there, and we can now run the setup program. So this is going to start a web server process, and when it's up and running, it's going to give us a URL to connect to. So with the browser window open here, I'm going to go ahead and connect to that URL. And that is https localhost.local domain :8446 is install. So that just came up over here while I was typing. So I'm going to go ahead and hit enter. Now, one of the other things I'm going to do, and I'm going to come back to this window in a second, is start a tail on the log file that we're going to follow, and it's going to give us more detailed log messages than during the installation process than what you're going to see in the installation wizard. So tail -f tmp IBM islogs is. There we go. So that's the log file. We started our tail. Let's go back to our browser window. So here we're just going to go ahead and accept this warning. It's basically telling us that the certificate presented by this particular URL is um, is a self-signed certificate. So it basically, your browser will throw up a warning. And so we just simply accept that because we know we are going to a trusted source, and it's a one-time install, so it's not a URL that you will have users connecting to. So it's safe to accept it. Click on the login button in this installation wizard to get the installation process going. Okay, so here we have the some links here for system requirements, release notes, etc. We're simply going to say next, move on to the firewall requirement. Now, because everything is being installed on your local virtual machine, we don't really have a firewall running here. I actually take that back. We do have a firewall running. It's called IP tables. But the firewall is set to allow all connections, so it's really not filtering anything. So we don't have to worry about this particular um, requirement. So click Next, and it's performing a quick check to see we have all our ducks in a row. System requirements are met, so we'll simply say Next. It picks an installation directory, which is /u02 IBM Information Server. I think that's what we want, so everything goes in /u02. So we'll say Next. This is a new installation. We already installed the repository, so there's nothing, we're not going to select this. This is typically if you're going to install a DB2 repository, you would choose this, and it would create a DB2 instance with all the objects in it. So we're not doing this. We'll go with services and the engine tier. Okay. Click on select all. We're going to install all of these products. Okay. Now go next. We accept the license agreement. Say next again. We're not doing a high availability cluster configuration, so we'll skip over that. We're going to install the WebSphere application server network deployment, so just stay with the default option here. So WebSphere is going to be installed in /opt IBM location, and then the shared resources directory is /opt IBM as well. Now we want everything to go in /u02. So what I'm going to do is, rather than change this to be /u02, which I could do, I'm going to go in as root and then go to /opt, and over here I'm going to create a soft link to /u02 IBM. Now, I don't know if /u02 IBM exists yet, so let's quickly verify that. And it does exist, so we're good. We'll go back to opt, and we'll say link -s /u02 IBM to here. It says file exists, which is good. I think I may have created this before, but just to show you for completeness, that IBM is a soft link in the opt folder, and it points to /u02 IBM. So that looks good, so we don't have to change anything here. Okay. And one of the reasons I like to do this is because any future patches or any upgrades that we do, and that involves running scripts that may have this path hard-coded /opt/IBM, we won't have to worry about tripping over that. So this helps us with that sort of thing. So click Next. So here it tells us all the ports that it's going to set up for us. The two main ones that I like to point to is the WebSphere port 9043 and the information server and the secure port for WebSphere 9446. So these two are being chosen for us, which looks fine. The rest of the ports I'm not going to worry about too much. Let's move on and say next. One of the things I'd like to keep an eye out for is all of these log messages that come up. I'm basically anything that's info is good. Anything that's not info, i.e. warning or error, might be something that we need to follow up and look into. Um, so keep an eye out. As long as you see info, everything's good. Okay, so back over here, the application server administrator account is called WAS admin. We're going to stick with password Oracle. Click Next. Information server admin, IS admin, password is Oracle. Everything's Oracle on this machine. Here it's asking us for the connection to the metadata repository. So we already created that separately. So we'll simply provide the connection information. It's Oracle 12c on localhost, port 1521. Database name is ORCL. And then username is xmeta. Password is Oracle. And repeat that here. Now when I click next, it's going to try and connect. And looks like the connection was successful. And now we're going to do the same thing for the staging repository. So it picks up the same connection information. Username is xmetasr. Password is Oracle. And we repeat that. Then click next. And it was able to connect successfully, so that looks good. The port selection for job monitor ports, we'll leave that as is. The engine tag ADE is fine, so we'll click next. Data stage administrator, we're going to use an existing user, DSADM. Password, as we know, is Oracle. So we had created this account in an earlier step. So now say next. And now install globalization support. If you want to do that, why not? Let's say next. We are not going to do the MQ plugin, so skip over that. SAS. Server agent port configuration 31531 for ASB agent port looks good. Let's say next. Operation database. So we're going to skip over this. This is creating a DSODB schema in one of our databases, and the purpose of this is to store all of the logging information that gets generated during the job execution. So it's when you use the operations database console from your information server launchpad, you can actually see all the jobs that are running, the resource consumption at the server level, etc. In a separate video, I will show you how to set up and configure this. So for now, we're just going to skip. Data stage addition, we're going to do the parallel and server job, so the default is what we want. And this is if you want to create a starter project. So let's go ahead and say yes, or check that on and say next. Analyzer database connection. So we did create this at the time when we did the metadata repository. So I'll simply provide the connection information to it here. Database name is ORCL. Username is IAuser. Password is Oracle. And say next. Standardization rules repository. Do you want to create that? Um, we can. We'll just say Oracle. This is a schema that will get created later on, but we didn't create this separately as yet. So just say next. SRD user is the account that's created. Now it's going to do another final requirements check in more detail. So far, no errors here. Everything says info. That's good. So everything passed. We had no issues. So we can say next. So it's asking you, do you want to create just a response file or do you want to install it as well? So we want to do the installation and our settings that we just, all the prompts that we went through to get to this point, all of that will be saved in a response file. So we'll say next here. This is the pre-installation summary. Everything looks good. And we're going to go ahead and say install. So here it goes. Now this process will take a while. I don't know, maybe an hour or more than that. So while this is running, we'll come back to it, we'll check periodically, but everything should go smoothly from this point on. So just checking here on the status of our install, looks like it's going pretty smoothly. We are well over an hour into it, and looks like we're 2/3 of the way through. So um, we'll just keep an eye on it, and hopefully it'll finish up in another 20 minutes to half an hour. One thing I did bring up is a system monitor here, which is basically a application available under um, applications, system tools, and then you can bring up system monitor from here. So that brings up this window, allows you to see how the resources are doing on your virtual machine. So our installation has finished successfully. It ran an hour and 6 minutes. And these are the list of components that were installed. So pretty much the entire information server suite. We can click finish here to exit our installation session. Now, one thing we can do is go to a terminal window and we can run a ps-ef and grep for IBM to see all the IBM processes that are running. And there's quite a few. So this is what we just installed. And if I look at the number of processes running, it's about 11. So this completes the installation part of the information server software. The URLs to get to our web server, WebSphere instance, and information server would be localhost.localdomain:9043 IBM console. So this will, again, we'll go ahead and accept the self-signed certificate. And this will bring up our WebSphere console that we just finished installing. WAS admin is the username. Password is Oracle. And this should log us in. And so we're in as WAS admin. Similarly, if you want to go to your information server console, and that would be https localhost.localdomain:9446 /IBM IIS Launchpad. Again, for this particular URL, we also accept the self-signed certificate. And this is our information server launchpad. In a future video, we're going to set up our client tools and connect to this installation that we just performed and try to run some jobs. Thank you for watching.